Okay, Algebra 2, Module 2, Lesson 15, what is a trigonometric identity? It says April claims that 1 plus cosine squared over sine squared theta is equal to 1 over the sine squared theta. Is an identity for all real numbers theta that follows from the Pythagorean identity. Now, this is a weird question because it doesn't even answer that really until C, and so it kind of walks you through this question. So A says, for which values of theta are the two functions, f of theta and g of theta, defined? What does it mean? When would they not be defined? Is probably the best way to answer this question. When would they not be defined? Think of your extraneous solutions. What makes these not work? When are they undefined? When we've got fractions, what do we always look for? A what? Somebody said something. What are you looking for with a fraction? When is a fraction undefined? When you have a 0 in the denominator, yeah. That's what you're looking for there. So we would say that these are undefined when what? Undefined. What did you say? When sine of theta is equal to 0. When undefined when sine of theta is equal to 0. Now, when is sine equal to 0? So theta cannot equal what? When is sine 0? When is the sine 0? When it's what? I can't hear you. Okay, 0 or... If we're looking at our unit circle, when is sine 0? At 0 and at 180. That's when sine is 0. So how would we write that as far as radians? We would say theta cannot be k pi. Any number of pi's. It can't be 1 pi. It can't be 2 pi. It can't be 3 pi. It can't be 4 pi. It can't be any value of pi. It cannot be. Does everybody see that? That's when your sine is 0. And we would say we have to define k, so for all real k's. So we wouldn't say 1.4 pi. It has to be 1, 2, 3, 4, 5. Okay? Actually, that's not right. All real? That's not right. It could be all integers k. So it could be negatives. All integers k. Okay. B. Show that the equation follows the Pythagorean identity. Well, what is the Pythagorean identity? Okay. Equals 1. Yeah. So same thing. A squared plus B squared equals C squared. C squared here is always what? With a unit circle, it's always 1. Our radius is always 1, right? So we're going to say sine squared plus, and all right, I don't like writing this, but I'll go ahead and write it. Sine squared theta plus cosine squared theta equals 1. Now, we've got to get sine on the bottom, right? According to that equation, we have sine in the denominator, which tells us first of all what? Sine cannot equal 0, so let's write that. Sine of theta cannot be 0. If it's 0, it's undefined, it doesn't work. Okay? Now, how would we get sine in the denominator here? What does it mean when it's in the denominator? It is what? Divided by. So we're just going to divide by sine of theta all the way across. Okay? Sine squared theta, sine squared theta, sine squared theta. Now, rewrite it is all you have to do. What is sine squared theta over sine squared theta? What? 1. I thought you said 4 for a second. Okay, yeah. It is 1 plus cosine squared theta over sine squared theta equals 1 sine squared theta. There we go. It's exactly what we got. All we had to do, look at our equation. We see that somehow they divided by sine of square theta because it got on the bottom somehow. So let's try it. Divide everything by sine squared theta, and it ends up being exactly what your problem was. So yeah, it does follow as long as sine's not 0. Okay? All right, go to page 2. So it says, is April correct? Well, go back to page 1. What did April say? April claims that what we just found is an identity for all real numbers theta that follow the Pythagorean theorem. Pythagorean identity. Is that true? Why? Exactly. She said it was for all real numbers. Is 0 a real number? So she is incorrect. So yes. Is April correct? No. Sine cannot be 0. Okay? Very good. Which means sine can't be pi, 2 pi, anything like that. Now, what else we got? Write equation. Okay. In other terms of other trigonometric functions and state the resulting identity. Okay, so this means just pick something and just rewrite it. We can, because we have sine and cosine, we can rewrite these into different trigonometric functions. Okay? Because if you have sine and cosine, can you have tangent? Yeah, because tangent's just sine over cosine. So you can rewrite these in different terms. So what they do, let's see here. They say, okay, instead of tangent, they're going to do, okay. So look at this right here. What's another name for that? What's another name for cosine over sine? What's another name for cosine over sine? What's another name? Cotangent. Yeah. What is another name for 1 over sine? Cant? Cosecant? Sine? If you inverse that, that's what? Cosecant. Right? Remember, you got to do the opposites, or the way I remember it. Sine, the inverse of that is cosecant. Cosine, the inverse of that is secant. You change the S's and the C's when you're doing inverses. Okay? So we would write this as 1 plus cotangent of theta is equal to, what do we say, cosecant of theta? That's the exact same thing. But when you rewrite it like this, you still have to remember what cannot happen here. Even though we don't have a sign in here at all, we know that cotangent is cosine over sine. Therefore, what? Theta cannot be what? It still cannot be any form of pi because cotangent is cosine over sine. If sine is 0, it's undefined. So even though you don't see sine in your problem or in your equation, you still have to think about what would make this an undefined equation. Okay? Just like if there was cosine. What if cosine was in the bottom? What would we have to say? Theta cannot be. What can theta not be if cosine is in the denominator? Yeah, so pi over 2, any form of pi over 2, right? So we would say it cannot be k pi over 2 because that's when cosine is 0, right? You always have to think about what we call extraneous solutions, okay?